Miss Kim?
That was numbers 3 and 4. They're still number 15.
What do you call that?
That's
Waterfall?
no simple. That's like on the
Somebody
I
else
know.
put it
That's why we
air
should
stick.
have easily done
Can I
it.
get an air stick for that?
In fact, you have 25 minutes in this class.
Why are you rubbing in my face, bro?
Because it's, I was going to say it's been, 34 weeks, but it's also been 34 weeks plus, the 27 weeks from last year. We're still not doing the homework.
Oh, I didn't know.
All right. Hey, what questions do we need to ask off of these problems? Devin, are you sure you did your homework? Because I just remembered I think someone sitting at this desk left their homework yesterday. Could that have been you?
Miss Kim.
Devin, you're supposed to have a thing just for my class. You should not have to be digging.
Do that question, Miss Kim.
What?
It's a simple question. For number 3 and number 4.
Yeah.
Why does one have a like the vertex line, I guess you call that? And
I
another
said
one
I
doesn't?
want you.
Oh, the axis of symmetry?
Yeah, that's the change.
I just forgot to put it in
That's
there.
not available at this moment.
Alright.
That's available.
I mean, I wrote the equation for the axis of symmetry. I just forgot to draw it. Kelsey.
Sir?
Are we all good on these questions? There are none.
Yes, no questions.
We're good on the question.
Because I'm just
Good on the
a hard
questions.
worker that I already understand.
There we go. Focusing on the important things of how hard we work.
I'm so smart.
Going once, going twice,
Sorry.
sold. Here's number 15. Alright, we're going to talk about a couple of things here. So I do want to point this out. This question I knew was going to be harder.
Yeah.
As long as you put in some work, I was going to be okay. You just had to try it. Because I was going to talk about it today. So one of the things I want to point out is,
Excuse me.
just looking at this table here, I do not expect anyone to have been able to write this explicit equation. Just looking at the table, I don't necessarily expect you to have written the explicit.
Sign it.
Huh?
Then why'd you do it if you knew we would be able to?
Hold up. Just because you can't write the explicit equation right away, like you'll start to figure out how you can later, what could you have done right away other than write the equation?
You can tell the line of symmetry, the vex point, the...
You could tell the line of symmetry. Notice how there's symmetry around this point. But guys, what is B?
Graph.
A graph. Can you create the graph off of those points without knowing the equation?
Yes.
Yes. So that would have been a great place to start. -3, 2, -2, -3, -1, -6. Right? You had all the stuff you needed
Yep.
to help you get started there. So there,
Is a parabola.
a parabola.
Sorry.
Trying to do the Shelby parabola.
I didn't want to say that. 'Cause it's weird.
Alright, so there's the parabola. Okay. Now notice it does say compare the values in the table for g of x to those of f of x. I want you to notice 0, 0 is right here. But it went from 0, 0 to 0, -7. So what happened?
Oh, so a
Minus
-7.
We subtracted 7. Does that hold true from 1 to -6?
Yes.
4 to -3?
Yup.
9 to 2?
Mm-hmm.
Yeah. Remember, they already gave you what's called the parent function. You don't have to know that name, but that's called the parent function, just y equals x squared up here. Notice, that is this function.
It makes a little baby one.
Well, it's just that it hasn't, this one starts further down. But I want you to notice what happened to this orange parent function.
It went downer.
Okay, what's the mathematical term that we talked about yesterday to say it goes down?
Decrease. It decreases.
Drop.
Drop. It. Translate.
Translates.
Oh, yeah.
Remember, a translate is a shift. Notice what I say right here. It translated down 7.
Yeah.
Right? We translated down 7.
Yup.
What's a key point, though, that we can see that tells us it was translating down 7?
The 1, 0, 0, and the on the bottom, bottom.
But there's one single point that makes it easy to see that it translated down 7. The line
The
of
vertex
symmetry.
point.
The vex point.
Vertex
Well,
point.
That vertex
Line of
point.
symmetry, vex point.
Yeah, I'm the first.
Actually, yeah, line of symmetry and vex point.
Well, okay, one thing I want to clarify. Remember, this is my line of symmetry.
Right, it goes off vex point.
Say it one more time.
It goes off the vex point.
The x point?
The vex point.
Are you talking about the vertex?
Yeah.
Vertex.
Vex.
Vertex.
Vex, not vex.
It's not vex, it's vertex.
Vex sounds better.
Okay, but that's not what it is. It's a vertex. Okay, so please notice that vertex was translated down 7.
Mhm.
Now, Shelby, you did not write your answer exactly like this. How did you write your answer?
Well, I didn't know what to put for A, so for like the thing that's shown. Okay, but after that, I put parentheses x minus 0 squared plus 7.
Plus 7?
Oh, no, minus 7.
Minus 7. I want y'all to notice, and she said, I didn't know necessarily what to put for A. What form of a quadratic equation is Shelby using there?
She's using the first one that's on the sheet.
What's that called?
I don't understand. I mean, vertex form.
Vertex
Yeah,
form.
there it is right
Hey,
there.
by the way, what did we just talk about was translated down 7? The vertex. Y'all, if you have the vertex, what would be a good equation to start with? Vertex form, right?
Yeah.
We want to recognize that starting with the vertex form here is a very efficient thing to do. You have a vertex. Now, if you're not writing down the note, hey, I should probably note the vertex. You're going to miss out on important details here. If you have the vertex form of the equation is a good place to start. I see one student writing it down, 2 students writing it down.
I'm thinking about it.
Wait, what are we writing down again?
The fact that the vertex tells us that we have the vertex, so the vertex form
Oh, okay.
is a good place to start.
So can I put vertex equals vertex form?
I mean, when you say that, you're saying literally that the vertex is equal to the vertex form. Is the vertex itself on its own equal to the vertex form?
No, not that.
So let's be clear with our language. Maybe if we know the vertex, then start with the vertex form.
Okay.
Okay? And so you can use shorthand like that, but I would still write it all the way out. Right? This part where I say it's a vertex form of a quad equation, right? Quadratic equation.
Yeah.
Use shorthand, sure, but like, be clear with your language. So I want y'all to notice, right? And so Shelby even said you weren't sure what to put for A?
Mhm.
Okay. I'll go ahead and tell you we'll get more into A later, but for now, go ahead and make the note to yourself, numbers 15 through 18, A is equal to 1.
What?
Wait, 15 through 18?
Yep.
A is equal to 1.
Yep. Numbers 15 through 18, A is equal to 1
Okay.
for all of those.
Why?
I'm telling you it is.
Oh.
Okay? So I am going ahead and telling you that A is equal to 1. As I said, we'll hopefully get a chance to explore it more before the end of the school year, but for now, just A is equal to 1. Notice, though, from there, what was the vertex of this parabola, of this quadratic function?
0, negative 7.
Oh, it was x minus 0, h, plus a negative 7, that's my k, isn't it?
Yes.
If you can identify the vertex, which is where that symmetry is going to be, that vertex form is going to be very useful there.
Yep.
So pay attention to that. And so, Shelby, yes, you can now hopefully notice that's my vertex easily and be able to write the equation from there, but you can always make that graph to make it easier. Okay, and so it was translated down 7, and we know that because of the minus 7 at the end of the equation. Yes, ma'am?
What is 1 squared minus 7?
Negative 6,
Oh, okay.
right? 1 squared minus 7, that's 1 times 1 minus 7.
And then 2 squared is 4.
Minus 7 is?
Negative 3.
3 squared is
9.
9 minus 7,
2.
2.
I'm hardworking.
There you go.
I'm sorry.
Alright, any questions off of 15, or do we feel like we could apply this tonight for number 17?
I feel like I'm a hard worker enough to apply this tonight.
Good, that's what I like to hear. It's only taken 35 weeks out of 36, but we're getting there. All right.
Still
So-
gonna do the period before this.
What did you say?
Nothing. Don't worry about it.
I'm scared. Alright, so we should already be logged into our computers. We should be in Desmos. We should have typed in the activity code.
Whoa, that's a lot.
Okay. So that's at least better than 0.
I always get a headache with this.
Okay, so you have that.
No, you don't, Sheldon.
Alright, so we should already be logged into Desmos, and we should have typed in the activity code for Desmos. If you have not done that yet, do that now while I'm going over the objectives. So be logged into Desmos, type in the activity code for Desmos, but let's look at the objectives while a handful of us are still doing that. So remember, we are still looking for making use of structure. There are 3 different quadratic equations that we're focusing on. And we need to understand the patterns within those equations and what the different values of A, H, K, A, B, C, A, P, and Q mean for each of those equations. So, what are those different equations called? What are these different equations called?
They're called vertex, standard, and factored
So the
forms.
vertex form of a quadratic equation, right?
Yeah.
The standard form
Uh-huh.
of a quadratic equation and the factored form.
Yes.
Knowing how we move in this class, we will probably get towards the end of the slides or finish the slides today. So be aware that is what we're trying to work towards. I believe yesterday we got all the way through the vertex form and talked and looked at the table, didn't we?
Yeah.
Yep.
Sound right?
We're on like 7.
Beautiful.
That's it.
Okay. Quick couple of notes. I do want you all to flip over to the back page where you made whole class discussion notes yesterday.
Yeah.
And I want to make sure that we remember these details. So in the vertex form, what is the point of that A? What does A do to the parabola? What you got, Kelsey?
Oh, I thought A was 1.
Huh?
I thought A was 1.
Well, so remember on the homework, A is always 1.
Oh.
But we looked at A yesterday and we slid the slider back and forth.
Oh, okay, sorry.
What does A do to the parabola?
It makes, wait, can you move it?
Oh, I need to go back to the... Go on.
I think it moves it up and down.
You think it moves it up and down?
No,
huh?
just kidding, I don't know.
No.
It's,
Well,
hold on, let me go
yeah.
back.
Alright, so here's A.
Uh-huh. Oh, it makes it skinnier and, oh wait, no, and up, and, yeah. Negative is going down and positive.
Say again, Julia.
Concave up.
Ah, so A is controlling the... What does A control?
It controls the concaves, either the
Concavity.
Concavity, so whether it's concave up or concave down. Really quickly, I want to point this out, notation-wise, when you're writing about this, I've seen a lot of students doing like capital A or something like that. Instead of doing a capital A so that it doesn't get mistaken for a word, just put A with quotation marks around it. A controls the concavity. That's how we would write that to make it clear that we're talking about something specific, that that's my noun and not the article A, right? A, and the are articles. So that's how you would indicate
yeah.
that we're talking about the coefficient A.
Yeah.
We go with that idea?
You're bringing English into this?
Yes.
Okay.
Do you know what math is?
Yeah.
What is it?
It's a language.
It is a language,
Beautiful
right?
language, I guess.
Good,
Oh,
that's
yeah.
right. It is a language to make sense of the world around us, and so English interacts with that. We got to be intentional about how we communicate with things. Okay, so A is controlling the concavity. What does this H do?
Move it, because I forgot.
What's the mathematical word for move it?
I mean, shift it, or translate
That's
it.
a good word, but the better word is
Translate it.
translates. Which direction?
I forgot it.
Oh.
Can you click it?
Can I do it?
Yeah, please.
Horizontally, maybe?
Yeah.
Yeah. Notice, what's the letter again?
H.
And so it translates it
Horizontal.
horizontally.
Wow.
Oh my gosh, it matches up.
Genius.
It does not do that with the K,
Yeah.
but the H does match up to the idea that it's horizontal. It's a horizontal translation.
Look, I know how to remember it. K is for Kelsey, and she's vertically challenged.
I was not ready for that, and that was amazing. Woo! Okay. So K does what?
What? Up and down, vertical. Vertical challenge.
Alright. I don't know how everyone's not dying right now. That was hysterical. So, I do want to remind you of this. That means if I put H comma K together as a point, what am I looking at?
You're looking at horizontal and vertical point, which is an up and a down, which is a slope. So M.
So M?
Just kidding. No, it's a point.
It is a point. Now remember, M is a constant
M, constant,
something rate of change.
additive.
Additive. Do we have a constant additive rate of change?
No, you don't.
No, because it's not linear. That's parabolic, right?
Yep,
Or
sure.
quadratic.
Yep.
Come on, what is H comma K together? We should have made notes on this under the whole class discussion.
H and K. Oh, I have it right here.
It's the what?
Coordinates of the vertex.
Ah, that's my vertex. Remember, if I look at how far I was translated to the right, and then how far I was translated down, or left or up, there's my vertex, right?
Wait.
Those
what?
translations are affecting the vertex. It actually affects every point, but it's easiest to see in the vertex. The one thing that I realized we didn't talk about yesterday, so you'll want to write this down, axis of symmetry. There is a very clear pattern for the axis of symmetry, for its equation. What is the equation for the axis of symmetry?
It's gonna axis of symmetry would be x equals something. The point that it is
The point of the vertex.
this line.
So x equals 6.3 comma negative 4 here?
In this case, yes.
Just the 6.3?
Wait, what are we looking
So Peyton says that it's just x equals negative 6.3. Is he correct?
at? I can't see that far, but probably yeah.
Probably yeah.
Probably yeah.
So which value is Peyton referring to?
He's to the x h.
To the h?
Yes.
So x equals h?
Yeah.
Alright, so I want you to notice, because we can actually quickly check this, x equals h. Is that the axis of symmetry?
Yes.
As I move h, does that stay the axis of symmetry?
Oh my gosh.
So does x in fact equal h?
Yes, in fact it does.
In fact it does. Alright, so at this point, did we go all the way through this table yesterday or no?
You only did half, but I completed it.
You completed it?
Yeah.
Okay, just do the top half?
I did all of it.
You did all of it, but as a group, as a whole class, we only did.
Oh yeah, you
I
only
did
did
the
the
first
top
two.
half.
Okay, let's do this then. I'm gonna make another one up. Y equals negative 3 halves times x plus 3 squared plus 4.
Three comes
Okay, so
Okay, so what do we think our vertex will be?
3 comes there, x equals 3.
So x is equal to 3. The y value is
17.
17. Does anyone disagree with that, or are we all in agreement?
We all
I
agree.
agree with Peyton.
We all agree with Peyton.
Wait,
When does negative?
negative, yeah.
Yeah, negative 3. I think it's,
Oh, why is it negative 3?
Because you're originally minusing.
Okay, so it should actually be negative 3 comma 17?
Yeah.
Okay, so we're all starting to agree there, but does anyone know how we could quickly check to make sure that's right?
Make a graph thing.
Make a graph, right? Remember you have Desmos
Desmos.
right in front of you. So go to Desmos. I did y equals, oh by the way, concave up or down?
It's probably gonna be an up, a down, a down, a down.
Why is it concave down?
Because it's
Negative
negative.
3.
Yeah, negative.
So this negative 3 right here is what's making it concave down?
No, the
Oh, wait, no, it's a 17 and it'd be concave.
No.
So this 17 is what makes it concave up?
No, I don't
No?
know. I
It's,
don't know.
okay, y equals negative 3 divided by 2, that's what makes it.
Remember, A is what's defining the
Oh yeah,
concavity,
true. I wrote that down.
right? Okay, so let's check. Oh, and then what would be the axis of symmetry? X equals,
Negative 3.
so we're predicting x equals negative 3. So negative 3 divided by 2 times x minus, no, plus 3 squared plus 17. So is it in fact concave down?
Yes.
Yes, right? And notice if I take away that negative from the 3 halves, is it concave down now?
No.
So it is that A that's defining that. Notice what is the vertex?
It'd be negative.
Negative 3 comma 17, right?
Yep.
So we got to remember with that h, it's x minus h, right? So h would need to be a negative 3 to get x plus 3.
That's gonna trick me every time.
That's why we need to learn it well, because if we pay attention, it's always going to happen like that.
If we pay attention, it's gonna be on the.
You gotta engrave it into my head like you do the other thing that you engraved in my head,
Good.
which was multiplication, repeated, and something. And,
Repeated addition.
yeah.
We engraved it real good, huh? Alright, so we should at least be on the standard form here. Pay attention to all the different value, or what you're supposed to be manipulating, sliders, things like that. I do want to point this out, okay? So we have our standard equation. Go ahead and write down these terms or these definitions to make sure we can communicate clearly. A is what? What is the A in terms of this equation?
Equals
The
the concavity.
concavity.
Well, okay, so you're assuming that it's going to define the concavity. Sorry, I should have clarified this. A is being multiplied by x squared. What do we call a number being multiplied by a variable?
You should,
Constant. Coefficient.
Coefficient. Make this note to yourself that A is the coefficient of the some kind of term. What term is x squared?
The quadratic term.
Okay, x squared would be a quadratic term. Alright, B is the coefficient of which term?
Wait, B.
Yeah, ax squared plus bx.
Oh.
Remember, that's our standard form we're now looking at. So b is the coefficient of the,
I don't know that one.
well, what if it's x to the first power? We have quadratic, then we have what? Linear, right? B is the coefficient of the linear term. Remember how line, it was always mx plus b, so x was to the first, or m times x minus x1 plus y1, again, x to the first. So if it's x to the first, it is a linear term. And so what would we say c is? C is a constant, right? There is no variable with it. So hopefully that will help you in your language and your discussions. A is the coefficient of the quadratic term, B is the coefficient of that linear term, and C is a constant. So start working with your sliders, observing what happens, recording your thoughts on the next screen, but then have that small group conversation to really make sure we understand it.
Alright, well,
Yes, sir.
I didn't take notes on this.
You did not?
Yeah, we talked about it and take notes.
Okay, then if you remember what you think it is, then go for it.
Okay, I don't know.
Well, then go back to the previous slide and
We have to redo it.
play around with A.
You told me I didn't have to do it.
Huh?
You told me I didn't have to write anything down
Why not?
because we were running out of time.
Right, so go back to the previous slide though and figure out the answer.
Alright, we'll go to slide 4.
Oh,
Yeah.
we already took notes on that. Go ahead and move on. I thought you were talking about something
I
else.
didn't know.
That's Vertex Form. Yeah. So you already worked through all that though.
Yeah, we only did like 2 in class and I just finished it.
Yeah, that's fine. So go ahead and move on.
Okay, we'll
Yeah,
go to slide
so you're
7.
working there.
Go to slide 7. Player